thank you everyone for joining. I'm really looking forward to sharing this with you, and hopefully you'll find it useful, and we'll allow some time for questions and answers at the end, but as always, feel free to contact us. I'm just going to get started here. I've got a few slides to share. There's a bit of background information on this, and then I'll get into some actual software demonstration. So as an overview of what I'm going to talk about here, I'm going to talk about, first of all, the 2030 challenge itself, and then something called the AIA 2030 commitment, which is different but very closely related, something that comes from the American Institute of Architects, and then also talk about where we're at as an industry relative to these two initiatives, and then talk about Autodesk solutions, mainly Insight 360, but also how tools like Revit and Format can play a role in meeting these goals. And then, of course, I'll leave some time for questions and answers. And throughout the session, if you have any questions, please do put them in the question box, and Stephanie will take a look through them, and we'll try to get through them. If we can't get them all, we'll follow up afterwards through an email with more questions. So the 2030 challenge is essentially a series of increasing goals that get us ultimately to carbon neutral buildings by 2030. And the baseline is actually set against existing building stock as measured by the CBEX benchmark back in 2003. And today the goal is, and from now until 2020, the goal is 70% reduction on that benchmark. So it's a fairly aggressive goal, but then as you'll see, as years go on, each 5 years, that goal increases to 80% and then to 90% and then eventually to carbon neutral. So it is a stretch goal, and it's not intending for every project must meet these goals or you fail. It is trying to transform the industry and drive the industry in this direction. And certainly some projects can and do meet this goal. Other projects get close to it. The main thing is that you try, right? And that the idea of the 2030 challenge is essentially that whether your clients ask for energy efficient, low carbon buildings or not, as designers, architects and engineers, you make efforts to deliver a high-performing building regardless, and engage the owner in high-performance design and help them understand the benefits both in terms of running costs and also greater occupant comfort and so on. So there's a lot more to it than just what I've explained. That's it at a very high level, and there's a link there for more information. I'm sure many of you already know about it, but for anyone who's not up on the latest, you can find more information on it here. So just to point out as well, this challenge has already been adopted by many industry organizations, the AIA, ASHRAE, the Illuminating Engineering Society. A lot of major industry drivers have helped shape and influence and promote this. The Department of Energy, I could go on, many drivers behind this. So it is an industry-wide objective, and it is also globally applicable as well. Granted, different benchmarks in different countries, but it is something that everyone can relate to. And I think the critical thing that's worth pointing out here that we'll speak about is what's really interesting and what's really valuable about these goals is that they're speaking to a better outcome, not just a better rating. In other words, it's not good enough just to prove a low energy, low carbon performance on paper or in an energy model, but ultimately drive the building in operation to do that. So this really requires a sort of a whole life view of the building, and of course that starts in design and critical decisions are made in design, but it's very different to looking at a code benchmark, energy code benchmark, which first of all is not a particularly high bar, and also doesn't actually result in a measurable outcome, and I'll get into that in a little while. The AIA 2030 commitment, on the other hand, is essentially calls for all members of the AIA to aim for the 2030 challenge on all projects. And the words I've underlined there are really the key parts. That's aim for. In other words, you don't fail if you don't meet these goals. But the point is, we're trying to transition the industry, trying to educate more owners on the benefits of doing this. And so the first thing is to aim for it on all projects. And the other critical thing that people often overlook is that they want you to report your data. And I'm going to get into what that means in a little bit. Well, people often think of it just as the goals, but in fact, arguably an equally valuable part of it is actually reporting the data on your projects so that as an industry we can understand how we're progressing along the trajectory towards those goals. So again, you can go to the AIA to find out more about this. I'm going to dig into this in a little bit more detail, because this really has taken the 2030 challenge and put a very clear set of metrics around it, and with the reporting we're learning more and more as an industry where we're at and where we're going. So I'm going to show you later how you can sort of do this, but a critical part of what the AIA have done, really valuable, is that they've developed something called the Design Data Exchange, or DDX for short. And it's essentially an online reporting tool where you can report all your projects. At an individual firm level, the data is private, so you can see all your list of projects, you can see the energy use intensities that you're reporting, and you can see the energy saving strategies that you've committed to, and you can look at them like project by project or region by region or building type by building type. There's all kinds of interesting ways you can look at the data. But then at an overall level, at an anonymized level, we can see how we're doing as an industry, and the AIA publish an annual progress report. The most recent one literally only came out last week, and I've taken some excerpts from it. But that's public facing, so we can see where we're at, how we're doing, and where we're going, and what the trajectory is at. And so the DDX is really an important part of helping us understand where we're at, and having a data-driven way to drive us towards these goals, and to help us accelerate the industry transformation. So the DDX itself has actually only been out for a little over a year, and this year is the first year that the annual report has been based on the DDX information. Other than that, before that, it was a lot of manually gathered information. It was just a lot more work for both the firms to report it, but then also for the AIA to gather it. But these are some excerpts from the most recent report, and it'll give you an idea of where we're at, because it's kind of showing you some historical information. You'll see the link down below to the actual report itself. If you're, I would recommend you take a look at this. It's got a lot of really good information. But the first thing you can see is where we're at is the number of signatory firms and the number of reporting firms. So what you can see here is that as of 2015, we have 366 firms, and this has been growing steadily. That represents something like in the 80% of the top 20 A&E firms in the country. But there's still a lot of growth remaining. There's still a lot of firms that aren't aware of this commitment, or are but haven't signed up for all kinds of reasons, because maybe they're not clear on what the actual requirements are, or they're afraid that if they're not doing net zero projects that they're failing, and that's actually not the case. What you will see, however, is that even out of the 366 firms, only 152 are actually reporting. And the AIA recognize this themselves. That's not good, right? We need to do a whole lot better in merely just the reporting, because the reporting will provide us with the data to make these better decisions in the future. But then also the other thing that the AIA have also recognized is the fact that over the last 6 years now of reporting data, you'll actually see that the average energy use intensity reduction has pretty much flatlined. It's around 35, 38%. It's in that range. It's not going up. And so something desperately needs to change here, because that trajectory stays that way, we're simply going to miss those goals. So the AIA have been quite clear in sort of recognizing that the industry is in transformation. We have the tools to do this, but there's a lot more we could do, and really what it takes is just this commitment to make this. So out of the last couple of years reporting, I've taken a few excerpts, and I just want you to see, can you spot the theme here? I'm not going to read each one out, but it's very, very clear. In the last couple of reports that the AIA have produced, they are clearly calling out for more energy simulation, energy modeling for every project from the earliest stages to be carried out, and firms to make a real commitment to this, because that is the key to hitting these goals. It's simply not possible to hit these goals without doing energy modeling, and it's absolutely required that this happen. So we all know that energy modeling is something that has typically been in the domain of engineers or specialist energy modeling consultants. But the AIA now recognize that this is a skill that architectural firms need to develop as well. And ultimately, it is a collaborative effort, also including the owner, to get to to better outcome and a better building, because everybody needs to make their decisions. But like I said, these are just some of the findings, the key findings that you'll find in both the 2015 and 2014 reports, and there's just, like, the 2015 report is almost saying exactly the same thing as the 2014 report along these lines. So as you'll see, there's a very, very clear call to action around that. So what's stopping us, right? Why have we not moved the needle, and why, despite the main organization representing architects calling for this, there isn't more being done? And there is some growth happening. You know, you'll see there is sort of like 8% growth across different metrics and so on, but it's still not enough. There's still a big, big gap. And the reason we believe for this is that really the form that existing tools have taken. Right? So energy simulation, energy modeling has been around a very, very long time. You know, some of the really, like for example with DO2, they're like, the history of those are nearly 30, 40 years old. And remember, Energy Plus, the more modern engine, that's built on a lot of DO2. But these tools essentially have been around a very long time. They're very specialized and time consuming. They require a high degree of expertise. And they're very, very focused on precision. But there's questions about their accuracy. It's like the number one question we get asked on a daily basis. Well, how accurate are these tools? How will the energy model's prediction match with the actual building? That's a totally understandable and totally valid question, but it's actually very difficult to answer with these tools. And the reason is that they're focused on precision and not on accuracy. And let me just explain what I mean by that. If you take, for example, one of the many, many inputs to an energy simulation, such as the thermal properties of a wall, that goes into, an energy model goes into the layer by layer construction, and for each material layer, you'll specify things like thermal conductivity, specific heat capacity, and density. And you can get down to decimal places of inputs. And the question is to most users, if they don't know what that data means, or that they don't understand it or don't know it, then they don't know what impact that has on the accuracy of the model. And so that, first of all, creates sort of doubt in people's minds. But then also, the strength of it, however, is that if I was to make a very small change, I can see a very small difference, because the simulation is reporting down to like decimal places. But ultimately, it is only a single point of performance. And while it's showing you a very precise number of potential building energy, it's not explaining why. And what you've then got to do is not only the skill of building a model and inputting all the data and making reasonable assumptions, but then also knowing what questions to ask it. So you can also ask, well, is it valuable, and so on. And the reality is these tools in the right hands can provide a great deal of value, but they are still very limited to most projects. A small percentage of projects, like the big projects with big budgets, get to use energy modeling. And the value of energy modeling and energy simulation and all these amazing capabilities that are in engines like DO2 and Energy Plus, they're really not being realized because of the form they're in. To add on top of that as well, the sort of the dominant usage and knowledge that people have of these tools is really for energy code compliance and green building rating systems. And these sort of take something that's already kind of complicated and add a further level of rules and regulations and complexity around it. And ultimately, they provide a rating, but they're not pointing towards an actual outcome. So an owner can't base an investment decision on a 20% saving above an ASHRAE baseline, because that baseline can never be measured. So the existing tools, they play a role, but the thing is they're not in a form that really maps to the design process. And that's the reality. There's compliance energy modeling, there's energy modeling for HVAC systems design and analysis, because that's where the domain is typically relied. But from an architectural perspective, and particularly early on, and at the whole project level, energy modeling has not been in a form that the whole team can consume and collaborate on, and particularly architects early in the process, when it's so critical, can do a lot of analysis to really help inform design. So if that's the sort of existing sort of paradigm, the way we position Insight 360 is that it is a new paradigm. And this isn't just us saying this. This has been many of our customers that have already started to explore and use Insight 360 are now realizing that this really is an entirely different approach to the way energy modeling is done. And essentially the key elements of it are that, first of all, very clear indicators of performance and performance value, i.e. energy use intensity, or more critically, energy cost. Everybody understands cost and running cost, and that's something that's of interest to most owners. We then provide, rather than tons and tons of just output, what we provide is very clear cause and effect feedback on the major drivers of building energy, i.e. the major factors of architectural design, engineering design, and operational factors that drive building energy. Optioneering and comparison is built at the center because, at the end of the day, in order to get to a better design, you need to be able to compare and contrast and understand. So considering many different model options and many different factors and scenarios is a critical thing, and the whole user experience is built around that. Then critically, of course, it is BIM integrated, right? And not just from a single model state or from a specially created analytical model. What we've got with Insight 360 is essentially the ability to automatically create an energy model, high quality energy model, all the way from very early conceptual massing through to detailed design, right? So as you move from conceptual to detailed, and you go through different options and different levels of detail at different parts of the building, different facade designs, different interior space plans, your building information model contains that knowledge, and that can automatically be translated, and there's no need to create a separate analytical model. So simply by being able to analyze as you design, you're able to provide this information much more easily and help make better decisions throughout the process. So that's the sort of introduction and overview, and now what I'm going to do is I'm going to give you a demonstration and a sort of a hypothetical kind of use case so that you can kind of see how this tool is very easily very easy to approach and do on really every project, and that the extent to which that you take it is really up to you, but there's a certain minimum level of functionality that provides a very high degree of value with very low effort and very low risk to you as a designer. Okay, so I'm going to flip over now to demonstration. Okay, so I'm going to start this story actually in Revit because we can see the whole picture of things in Revit. This could just as easily start in Format at the very early conceptual mapping stages, because Format ultimately, as you model in Format, you're also actually modeling creating Revit files behind the scenes which can be opened up in Revit. The advantage of doing it in Revit is that some of the steps that happen are more visible in Revit. I'm going to walk you through that. But of course, the first step in doing an energy model is the model itself, right? And that's normally where people in the past have hit a barrier because they don't know what an energy model is, they don't know how to create one, and it requires that specialist expertise to create, do thermal zoning, etc., etc. Well, essentially, all of that knowledge is now being embedded in Revit, and the idea being that, if you can do basic architectural modeling in Revit, you can now create a very high quality energy model at the click of a button. All you need to do is just understand some very basic behaviors in the way that translation is actually done. So this example here, it's a very simplified representation of the design process of a building, where in this case, in most cases the building footprint and massing is pretty well defined based on things like the site and the program and so on. But obviously that's variable. As much as you can model and as much as you can vary your building model or your massing, you can analyze that as well. But the point that this is really showing is that you don't just start with this. You don't start with a detailed Revit model. That doesn't appear from nowhere. And in fact, by the time you get to there, you've made many critical decisions that influence building energy use, and you've got opportunities to make savings. So typically, energy analysis was starting at this stage, which is kind of too late in many ways. All you're really doing then is documenting building energy use, and you're not using energy modeling as a design tool. So if we start earlier in the process, literally from something as simple as a massing of the building, and just a representation of the overall building shape, even without placing any windows or glazing on it, we'll see how Insight 360 will help us understand how that building will perform with different treatments of glazing on different elevations. But then pretty quickly, we're hearing more and more from clients that they move from conceptual design stage into schematic and detail really fast, like in the matter of a couple of weeks. So very quickly that model starts to transform into something in between this detailed design. And in the case of this building, to sort of give you sort of a real example to think about. This particular building had nice views to the south. This main elevation that we're looking at here is to the south. It has nice views. So what do they want to do naturally? They want to maximize glazing. And of course, when you do that, there's an energy penalty for doing that. So how can we still hit these goals and manage that throughout the process? What you'll see here is we're starting with the massing. We could flex different massing and look at different massing schemes. But pretty quickly, once that gets settled down, we start to look at sort of feature facades and window placement. We end up all the way through to a detailed design. And the thing that I'm just going to show you here very quickly is how the energy model is created at all these different stages, and critically with a wide variety of modeling practices. So these architectural models in reality are not built for analysis purposes. And in the past, you always had to build the model in a particular way to do the energy analysis. That's not the case anymore. All that we require is that we say that the building is reasonably enclosed. That does not mean that it needs to be watertight. It just means that if there was, for example, no roof on the building, then we wouldn't be able to assume that what's underneath that roof is intended to be occupied space, right? So in other words, the energy model creation automatically identifies what we call analytical spaces, and it starts from as little as this sort of set of conceptual masses here, where once I have this set and I have mass floors enabled, if I look at the energy model, all I need to do is go create energy model. And what it will do is it will create a thermally zoned energy model. What we mean by that is when you've got nothing but sort of massing or open plan office space type configuration, we subdivide the interior of that building with the perimeter and the core, and based on different orientations to make sure that we capture the variation in heat distribution throughout the building, throughout the day as the sun moves around it. That's essentially the way a HVAC system would be designed. And remember, at this stage, we haven't even got an internal layout. You'll also see that in this case, we've parametrically applied 40% glazing to that energy model. We don't even need to do that, but that's literally just a setting that we need to set. But you'll see in the actual architectural model, I haven't made any decisions on glazing yet because we're going to use Insight 360 to help inform what those glazing decisions need to be. So I'm actually going to come back to these two later. But I'm going to start now at this very early stage. Remember, this could start at any stage, and what I would say is that if you haven't done energy modeling on detailed design projects yet, don't worry, it's still not too late. You can still do the energy modeling, you can report your data, and then in future start to look at doing this modeling from earlier stages in the process. Because you'll find this, a lot of people think this simplified modeling doesn't provide a lot of value, but you'll actually find it's extremely informative and is almost as valuable as the detailed model. The only difference with the detailed model is that you get to more design specifics later in the process. So starting with something as simple as conceptual mapping, if I simply set the location, that's the only other thing that we require you to set that's kind of project specific. When you click Generate Insight, that will send the model to the cloud and run the simulation. And then that will appear in Insight 360. So that everybody knows that they've got some history with this, Insight 360 is essentially a new skin or new user interface for Green Building Studio. Green Building Studio is still there. It's still used to do the cloud-based energy simulations, and all the results are still stored and saved and viewed on Green Building Studio. But Insight 360 provides a much better way to do comparison and view models over Green Building Studio. So what you'll see here is that you're seeing one for each of the Revit models that I created there. But you'll see here for this particular one that I'm starting with, what it looks like from the outset. So if I click into this model, you'll see what Insight 360 does. Now this is showing you the entire workflow, literally starting from nothing, and it'll show you how simple it really is to create these early stage models that get you on the path to making better decisions and then informing your next design decisions and capturing that in the building information model. What we'll see here is there's a couple of key components to it. First of all, this number in the corner is what we call the energy cost range, and you'll actually see that it's showing at the moment a number of $1.74 per square foot per year. If we wish, we can switch that over to energy use intensity. Some people prefer to work in that metric, but we like to generally show this in cost because, again, everybody has a better internal sort of sense of what cost means and what its value is. But you can see that switched over to EUI there. You'll see that it's actually, even though we're showing one number in the corner to provide very clear direction, it is actually a range. And in fact, that number that you're seeing is actually the mean of the range. And the range in this case goes as high as $5.85 to as low as 54 cents a square foot. And you'll see that there are two benchmarks in here. One is ASHRAE 90.1, which is essentially code compliant. And then the other is architecture 2030, and you'll see that it's much lower down. And that's what causes that little dial to go from red to orange to green. So red is above 90.1, orange is is below 90.1, orange is above 90.1, but still below architecture 2030. And when you hit the architecture 2030 goal, it will go green. So how is it calculating this range? So first of all, if you think about it, all we've told it so far is we've given it a model, something as simple as some massing, and we told it a location. And what Insight 360 then does is it essentially does a few hundred simulations which essentially parametrically vary all of the key drivers of building energy, and it computes the entire set of potential outcomes. So we know that the best of the best would give us 54 cents a square foot, and the worst of the worst would give us 585, and everything in the middle. And the current mean of all of that, sort of like an area type weighted mean, is $1.74. So it's a very wide range. And even from here, if I wanted and I went back and changed the model, I'd be able to see the relative difference on that one without setting any other thing. But it's a very wide range, and the point is essentially to start to look in and narrow down that range. So what you'll see here on Insight 360 is that each card here is an individual factor. So for example, we've got like building orientation, window to wall ratio on the south facade, shading on the south facade, glazing type on the south facade, and so on. And there's about 24 factors in there. Many of them are sort of grouped and related. They cover PV, operating schedule, and so on. I'm going to sort of get into some of these in a minute. But the basic user interaction model is as follows. If you think about the existing sort of tools and workflows require you to analyze a single configuration, like here's a building with this orientation, with this glazing, et cetera, and you'll get a certain energy use. Because we've run an entire range and computed the entire range, what we then get to see is what the actual value of each of these individual components are. So when we come to orientation, what we can see here is without setting anything else, we can see the best of the worst. So this little graph here is showing you that on the worst performing orientation is 315 degrees away from the base, which would increase energy. And the best orientation actually reduces energy by about, about 9 cents a square foot. So we can see that orientation, it does play a role. It's reasonably important, but it may not be as important as some people think. It really depends on the building geometry. But in this case, what we can see here is this little triangle. This is essentially what we call the BIM setting. So this is whatever was actually submitted from the model. So if whatever that orientation was, remember I mentioned that was a south-facing facade. In this case, I'm not going to change the orientation of the building. It's rare that you have that potential to do that. If you saw a very steep sloping curve here, it will be telling you that orientation plays a big role, and maybe there's something about the shape of your building that you should be looking at. But basically, very quickly, it allows you to assess something as simple as building orientation, make that decision, and move on to the next set of factors. So let's say, for example, let's then look at window to wall ratio, very common question, again on that south facade. What we can see here is, again, there's a much steeper curve. If we were to go up to fully glazed, you'll see energy will go up $1.77. If we went to no glazing, which may be not practical, but at least shows you the full sensitivity of glazing, you'll see it goes down to $1.60. So in reality, we're probably somewhere between sort of like 40% and sort of 100%, which, if you remember, that was the design goal, was to increase glazing. So the point is, I can see here that there's around, again, a 10-cent cost or saving, depending on what way I do this. So therefore, the really interesting thing is that if we increase southern glazing, if we want to compensate for that now, what we can do is we can implement some passive strategies, like, for example, adding shading, exterior shading. So if I show you, so you know what I mean, just let me show you the little graphic for this. So by adding exterior shading to each of the windows, again, parametrically here, we'll see that actually shading plays a big role. So for example, no shading, right, your energy cost, 100% glazing, you have no shading, your energy cost is going to be very, very high. If you went to sort of like 2/3 window height glazing, so quite extensive shading, you can see that's very, very valuable, right? 20 cents a square foot for adding shading. And maybe you don't know exactly how much shading you can add at this stage, but you know you can add some. So you can then target a broad range. The point of this whole interaction is that you don't get bogged down in the specifics, going back to the example of what's the specific heat capacity of the brick. That actually doesn't matter, because the factor, the main drivers, there's a bigger driver overall, which is what's the overall performance of the wall, along with all of the other pieces that are moving at once. So the point is you can go through each of these factors, window to wall ratio, shading, glazing, for each of the major elevations, wall construction, roof construction, infiltration, lighting efficiency, plug loads, HVAC systems, operating schedule, and even down to PV, right? So PV is a critical strategy for achieving the 2030 challenge in a lot of climate zones. And you can very simply see by percentage coverage of roofs. So you're not having to model a specific PV system. We've already computed that if you run this range of roof coverage with ranges of efficiency and payback, you'll get a certain energy saving for them. So it really allows you to very quickly strategize what your overall goal is. So the way to use this, that's the overall sort of workflow and user interaction. But the way to use this is essentially for each of these factors can be configured to represent some scenario. And in this case, what we've done is we've essentially, and I can store each of those scenarios. So the first scenario that I've created here was what we call a code compliant scenario. Okay, so in this case here, if you look down through these scenarios, you'll see it's like 40% glazing, and the roof construction is roughly in the middle, and so on. So basically, we now know, and you can see by the actual energy cost that it's very, very close, within a cent of the code. This is our starting point. This is the minimum that we need to do. Okay. And what you'll see here, for example, is window to wall ratio on the south facade around code is 40%. And notice that I haven't said specifically 40%. I've said a range, because there could be some, you know, I can have more on the south and less on the north, and so on. I can compensate because it's an overall building property. But the next thing I can do is if I increase the window to wall ratio on the south facade, you'll actually see here it's gone up to $1.47, because you see I've saved that overall setting, and that's the one change I made. So you'll see that if I build a code but I want my large window to the south facade, I'm going to have to do something to compensate for that. So what I can then do is I can, like I showed you earlier, I can go in, I can add shading, I can improve glazing performance. This is a full range from sort of single glazing all up to very, very high performing glazing. Each of these factors covers an entire range from sort of the very worst performing to the very lowest. So we get the full sensitivity of each, and essentially we're multiplying all those sort of scales across one another. But what I can then do is I can then find a sort of sweet spot on each of those curves, so I can essentially optimize the building envelope. And you'll see this greatly reduces the building energy cost now, because even though I've still got my 80–90% glazing, I've added some shading, I've got higher performing glazing, I've not put shading on the north or the west or the east, because there's not enough of a return on investment. You'll see, for example, I've got higher performing wall construction, roof construction, higher performing infiltration, etc. Because each of these things played enough of a role in the energy savings to say, right, you know, I'm going to do this. And again, a good example where people get bogged down are in things like the roof properties, or any of the material thermal properties. Rather than getting bogged down in the specifics of the actual thermal properties, that will come later. From here, you can basically very quickly see, okay, well look, roof construction does play a big role, but once you add any insulation at all, you very quickly start to work on the law of diminishing returns, right? So it goes from $1.20 to $1.15, but then from here, there's really no change, right? $1.14 across those three. So all we can say is we haven't decided the exact details yet, but we know we're targeting reasonably high performing roofs from sort of somewhere between code and very high performing. And you'll see that with only, like, you know, a few cents a square foot playing a role, we don't need to worry about the specifics of that at this stage, and we can continue to target our overall performance. So now that the overall envelope is sort of optimized, we can now look at, for example, improving the lighting power density and the equipment. These are other major operational pieces that we can assume, as well as the HVAC energy, and then ultimately have an overall strategy that essentially hits the 2030 goal. And so let me just take a little bit of time to update. So you'll see now this is flipped over, and the way we've done that is essentially we have sort of optimized everything, right? A better performing envelope, higher performing HVAC systems. We've even included some photovoltaic, around 60% surface coverage, and you know, assuming a certain payback limit. So the point is we've reached this strategy very, very easily, and we can clearly show essentially the path from, you know, doing nothing to increasing our glazing, to just building code, to optimizing our envelope, or LPD, or EPD, HVAC, and PV. So you can tell any story you want. You don't have to sort of export things to Excel or try to create special reports. This is the report, and it's dynamic and interactive, so that, for example, if a client asks the question, well, how will this building energy model relate to my actual building energy? Well, if they build and operate the building this way, it will use this much energy. Lots of work in measurement and verification with simulation has proven that. But the big difference why energy is often different in operation is that the building is operated differently. So the owner can see that the thing that they're responsible for example, are operating hours. So for example, here we've assumed in this case that the operating hours are somewhere between 12.6 and 12.5. But if, for example, this was a speculative office development and we didn't know the range, the actual building energy is probably going to be more like 49 cents with a wider range up to $1.50 as low as here. So if we say, okay, well, if it was all 24/7, it would be up here. If it was all 9 to 5 or 12/5, it would be down here. So the point is you can very quickly see the cause and effect of the major design and operational factors. And the team working together is very easily able to set these targets from the earliest stages. So remember, all of that is possible from starting with something as simple as a box, because we've looked after everything else around the thermal zoning and we've buried everything to really help you provide that guidance. So now that we have that guidance and we go in and we say now that we believe we can achieve that target even with our 80–90% glazing on the south facade, naturally we start to evolve the model and start to represent the feature curtain walling and so on in this model. And again, at this stage here, you'll see how the energy model now starts to take on more of the physical form of the building, the interior spaces and so on. And you'll see some of the really cool things that the energy model creation does, where in the Revit model that's like a single roof, but analytically for energy simulation, only part of it takes part in the sort of the heat transfer to the room, and the other part, the overhang, essentially causes shading. Okay? So in the same respect, we were looking at shading as a factor back here. This is shading as an actual design element or something that's in the building information model. So that when we go back later on and analyze this model, submit this to Insight, what you'll see here, let's go back a step. And what I'm going to do is I'm going to show you another little cool thing. But basically, we've got all these different models, and back there I created a scenario for PV. So I'm going to apply that scenario to all these models. Okay, so I can have these. I could have on the left-hand side where I've got 3. I have 10 different conceptual mapping options. I could have different detail design options, and I can very quickly apply those different scenarios to each. But if I go into this schematic design, what you'll see now, when I look at the window to wall ratio, remember earlier the window to wall ratio, the BIM setting was 40% because that's what we had parametrically told the model to do because we hadn't modeled any glazing. Now what you'll see when I go up here is that the BIM setting for the window to wall ratio is actually here it's worked out to be 80% is the actual window to wall ratio. So again, even at the schematic stage, I can say I'd maybe still tar 80–90%, but if I want to say that's exactly what I want to use, I can specify that. And then equally, now that I've got shading on that south facade, I can essentially say now I don't want any shading, because you actually see the line is now flat because there's already shading in the BIM setting. So basically, what this allows us to do is very easily scale from the very earliest stages through to sort of schematic design, all the way through to detail design. And in detail design, this is where energy modeling typically only starts when it's sort of too late. But what you can do is you can, again, Revit will look after the creation of a very accurate, high-quality energy model. So what you see here, this energy model is more or less proportionally accurate to the building information model. Energy models are only greatly simplified. And that's okay because they're used for comparative purposes, but there's really no need to do that simplification because Revit looks after that. And then basically when this is submitted to Insight 360, again, we'll see essentially the exact same workflow with Insight 360 where I have my model submitted and I'm applying factors to each of applying ranges to each of the factors. The one difference with the detailed model, or even the schematic model for that matter, is that pretty soon when you get into these stages, you do start to decide things like what are the properties of the roof, or what are the properties of the wall or the glazing, or in an interior layout, what is the room by room lighting power density or occupancy or equipment and so on. And if you start to specify that information in the Revit model, that gets used in Insight 360. And then when you look at, so I'm showing a floor plan here, you know what, open. So everybody knows rooms. Well, there's also spaces in Revit, and they contain occupancy, lighting, equipment, space type, things like that. All the sort of the classic energy model input settings. And the point being, you don't have to start with them. You can start much, much earlier. Use Insight to essentially guide your decisions as you go. And then when you get to this detail level of model, and if this model contained exact thermal properties of roof or wall, and exact specification of, you know, interior layout and space properties and so on, that will all be reflected based on the what we call the BIM setting, right? So again, you'll see here in this case the schedule here. That's exactly the building operating at that point of, you know, performance with that level of occupancy and so on. Which that's what's used in a sort of a compliance rating performance. But in actual design, you should really be designing for a range of operational performance, and that's something that you can kind of agree with the client and the design team. So you may want to assume maybe a slightly broader range, because you don't know for sure exactly what the range is. So in other words, it allows you to work with as much or as little specificity as you want, and allows you to identify design opportunity, and also manage operational uncertainty, and help keeping the whole team driving towards better performance. But ultimately, the ability to model from concept to detail, start with really something as simple as like a set of conceptual masses which anyone can model in Revit. Apply that to Insight 360, and then use the range of factors to help with broad targeting, and move throughout the design process with that immediate cause and effect. Use this as your reportage. I mean, you can certainly take this information out, but one of the really cool things again is the ability to add members. So I could add, you know, Joe engineer and Bob the owner, and that's this, to sort of say, hey, these are the assumptions that we're designing to. Do you have any views on these or opinions on these? And that's where engineers can advise on good assumptions for LPD or EPD, HVAC system assumptions and things like that, as well as the owner can start to understand that yes, their hours of operation play a role, something needs to be assumed, you know, and as they can see that that's a very big driver, then it helps justify more investment in that kind of decision to document that information to a higher level of detail. So that's essentially the overall demonstration of Insight 360. And there's one final thing I wanted to show before I finish, which is linking back to the 2030 DDX connection. So at any stage in this process here, you know, just to be clear, the AIA and the 2030 do an annual report, but they really encourage people to report regularly, not just do it annually and once a year. And that's normally kind of this big task for people because of this manual process. Now with the DDX, and also now with the ability to do it directly from Insight 360, basically all you need to do is, for any of these models here, if I just click this here and I go export AIA DDX, all I need for this is essentially an account with the AIA 2030 DDX, which any member firm has and will be given. Once I add that to Insight 360, what this will automatically do is it'll pull a number of fields from Insight, like the EUI and the window to wall ratio, etc., lighting power density. I can fill in some details, and then what you'll see over here is this is the DDX itself, and these are some of my projects. This is a test account where you'll see the most recent project, Cork's House, and so on. If I now go from here and I can simply click send, what that will do now is that will send this, the AIA DDX will send successfully, and then if I go into the DDX itself and click refresh, you'll see that this project was called Audubon, and you see Audubon, it's an office, medium 10,000 to 100,000 square feet. You've got a 63% reduction in EUI. There's the overall EUI, and I can click into it, and I can see that project details. So not only can I use Insight 360 for helping inform the design, but I can also use Insight 360 for automating the reportage, because normally all this information has to be put in manually, meaning at best it's done once a year. As you can see, we said only 50%, less than 50% of firms are reporting, because that's still seen as a major overhead. This provides you the ability to both do the analysis, drive the design to a better place, and do the reporting all in one. For more information, you can check out Insight 360 on the Product Center. You can check out Insight 360 itself. We've got our blog, which has all our announcements on product development and lots of learning content. And then also you can contact Microsol for more questions.